All right, so we have multi-correct questions with correct answers each. 68. Which of the following situations will increase the moment of inertia of a solid cylinder by the same amount? So it's all about the mass and radius. So let's see. So we would have mr squared. So in the first case, if we have a constant mass and double the radius, it would be m times 2r squared, which would be 4r. If we quadruple the mass and have a constant radius, it should be 4r squared, constant radius, it would be 4mr squared, which I think we have our answer already. So it looks like these two are the same. Now for C and D, if we double the mass, it would be 2mr squared. And for D, constant mass, quadruple radius, so that would be 16r squared. So it looks like A and B are our best bets. Number 69, a hoop of radius r rolls down an incline. Which of the following objects, if set in motion at the same time of an identical incline, will get to the bottom of the incline before the hoop? All right, so we know that a solid object will have a lower moment of inertia, which means it will have an increased angular velocity. So the hoop is, being hollow, is definitely going to be beaten to the bottom by anything that has a solid center. So we would have either B, C, or D. So we know that A is incorrect, but D is definitely a good answer because it's the only solid cylinder there. But now we have B and C are two solid spheres. The only difference is their radius. So we would say, okay, so if we increase the radius, we're increasing the moment of inertia, which would decrease its angular velocity, right? Let's look at that. So if we increase the radius, we're decreasing its moment of inertia. I'm sorry. If we increase the radius, we're increasing its moment of inertia, which would decrease its velocity. So we want one with the smallest radius. So B and D would be correct. Number 70, Leonardo da Vinci conceived of a flywheel with a variable moment of inertia. Consists of a vertical axis, with 4 rods attached to the axle on a horizontal manner, equally spaced. At the end of each rod, a small chain hung vertically with a sphere attached to the bottom. If an external torque was applied to the axle, it would rotate and the spheres would move outward and upward from the axle. Which of the following statements are true? Well, angular momentum is a conserved property unless we have a torque being applied, a force, and we do. We have a torque applied, so angular momentum is not conserved here because of the torque that's being applied. And we can also see here that as these masses that are hanging from the chains, as they extend outward further from the axis of rotation, our moment of inertia would increase. Just like the young woman who's doing the spins on ice skates. As she stretches her arms out, her moment of inertia increases. Angular velocity, in that case, would decrease. All right, so B and C would be our correct answers.